Good morning, everybody, or good afternoon, wherever you are. Um, so we've spoken about decisions, repetition, and now we're going to talk about um, this concept called try and accept, or I think it's called exception handling. Okay, or error checking. Okay. So in previous lessons, error checking was completed using decisions and repetition, if and while. So you would think that, for instance, like we want to see in one of the examples we did, we wanted to see if the user input a number that was between 0 and 100. So, and if they didn't, then we would print a different message for them, telling them what was wrong. Okay, so today we're gonna bring it all together using a new structure called try and accept. So error handling, try and accept. There's a structure in Python that helps us with illegal error handling called try and accept. If an error is encountered, a try block execution is stopped and transferred down to the accept block. So, okay, so let's read that again. If an error is encountered, a try block execution is stopped. So, if we encounter an error, then anything that would be in here inside the try block isn't executed. It's almost like an if else. We go to the accept and we run whatever is in there. So usually the try block is usually code that you want to run that does something, and the accept block is usually an error message that you want to send to the user if they've made a mistake. Okay, so here, so try num equals input. So we try to take input from the user and store it in num. And if that doesn't work, print uh, hey, you didn't enter an integer. Okay. So how can we loop this to force a user to enter an integer before progressing with the program? So here's an example. So we have a variable called keep going, and it stores the boolean value of true. So so while keep going is true, try to take the input. If you succeed in taking the input, then switch this value variable to the value false, right? So you don't want to keep going. If you've taken the input, you don't want to keep going. Otherwise, you want to print the message, hey, you didn't put in an integer. And then once that executes, you go back up here in the while loop and it goes while, and if keep going is true, then it will go back inside. So basically how this works, if you want to understand it, is that until the user inputs gives the correct input, meaning just an integer, we're going to keep asking them. We're going to keep telling them you've put in the wrong number, and we're going to keep asking them. If they actually put in an integer, then we do that and we don't ask them again, and we're out of the loop. So this is the basic structure for checking data types in Python. It can be modified to check other errors as well. Use this template moving forward. If possible, do not use while true to start nor break to end. So move away from, you know, doing things like while true or putting a break statement anywhere in the code. So here's a factorial program. So we're called a factorial program that we made. Um, so we take the user input, we take a number, we start with factorial of one. Well, we need to start the calculation off with one, and then we have a loop that goes from 0 to whatever number we put in that we input. This is how we calculate the factorial, and And then after the loop is done, we print this out. So the integer entered must be a positive number. The input must be an integer. What error checks would we have to perform in our program to ensure that it doesn't crash and or work unexpectedly? So the first check would be done using a while loop. So while num is less than zero. So it's if num is a is a negative number, print out you need to enter a positive number and then ask for the user input again. Okay, but how do we do the second check for an integer? So this is before and this is after. So we put it in a try except block. So we say done is equal to, we have a variable called done is set to false. And we say, so this not should be, I don't know if not is a keyword in Python or we just have the exclamation mark. Okay, so this is actually the negation of false, which is true. So while true again, try to get input from the user. If the input is less than zero, tell them they need a positive number. Else, done is equal to true. Okay. So that's the first check. And then here we say, hey, you didn't enter an integer. So we're checking two things. We're checking in here if the number is less than zero, and then here in this outer one, we're checking if they put in an integer at all, and then we do our calculation. Okay, so read a number from the user. So try it out yourselves. Read a number from the user and calculate its square root. What condition must you check for to prevent an error? Think about it yourself. Okay. So I believe. Okay, I believe this is the code yourself. Anyways, okay. So you import the math module because we're going to be using square root here, math and square root. So we need to import math. We have a variable called giddy up, and it's set to true. So while true, try to get a floating point number from the user. If the number is less than or equal to zero, print out this message. Else, change giddy up to false, meaning that we're going to exit the loop because we've got a good number. And if the user also, we're also going to put out a message if the number is negative, to enter a positive number, which is kind of redundant because we kind of already tell them here. And then we actually do our calculation here. Okay. So break is bad. So break is a cheap way of kind of exiting loops, but it's not recommended. So the above examples all avoided the format while true, followed by a break in the code. Use conditional formatting to control the flow of your loops as shown above. Use of break when it can be avoided will prevent work from receiving full marks. Consider break a swear word for code in this class. Okay, so we'll stop there and we'll continue on to the next.